So in this video we're going to look at the 1997 question 1a for linear acceleration applied maths. So in the question we have a particle which is moving in a straight line and it accelerates uniformly from rest. It continues then at a constant speed for time and decelerates uniformly to rest. The magnitude of the acceleration is twice that of the acceleration, so that's an important bit. The total distance travelled while accelerating is 6 meters. And the total distance travelled altogether is 30 meters. Total time taken is 6 seconds. So first of all, draw a speed-time graph and hence calculate the value of v. Even if they didn't ask you to draw a speed-time graph, you should always be sketching one out because it helps you kind of visualize what's happening and kind of pick the information you have and realize what information you don't have. So the particle starts at rest and it accelerates for a time until it gets to a velocity v. It then continues at this velocity for a time until it starts to decelerate at a rate which is twice that of its acceleration. So here we had a rate of acceleration a, we could call this rate of deceleration 2a. The total distance travelled, I'm going to call it S total, is 30 meters. And the distance travelled while accelerating is 6 meters. So we kind of split this up into stages and we call this stage 1, this stage 2, and this stage 3. The accelerating stage is stage 1. So the distance travelled while accelerating is 6 meters. So I'm going to write it in there because we know that the area under the graph gives us that number 6 meters. Total distance is 30 meters and total time, so I'm going to call it T total, is 6 seconds. So, although this doesn't look like it initially, the first thing we want to do really is we want to figure out, well, what's the distance travelled while it's decelerating? And the key really here is in the fact that they told us that if this rate of acceleration is a and this rate of deceleration is 2a, that gives us a ratio of accelerations. And if you remember some of the past questions that we've done, if this rate of acceleration is a and this rate of deceleration is 2a, the ratio of accelerations is 1 to 2. I'll put a for acceleration there. But remember, the ratio for both distance and time, we'll say s for distance and t for time, is the opposite of this. It'll be 2 to 1 for distance and 2 to 1 for time. So if it's 2 to 1 for distance, well, that means that the distance covered while accelerating at a rate of a is twice the distance covered while decelerating at a rate of 2a. So that means that this distance here must be 3 meters. That gives us a ratio of 2 to 1. So that's a nice little handy trick, but it's really important that you get that at the start because it kind of helps you with the rest of the question. And on here I'm trying to erase this, but it's not erasing. We'll just have to leave it there. So now we know that the distance covered while accelerating is 6 meters and decelerating is 3 meters, and the total distance is 30 meters. So 30 minus 6 minus 3 gives us the distance travelled while it's moving at a constant speed, which will be 21 meters. So we know that's 21 meters. So now find the value of v. So remember, when objects are accelerating or decelerating, we use the u-vast equations. So in stage 1 we're going to use u-vast. In stage 3 we could use u-vast because it's decelerating. But in stage 2 we just use v equals s over t. So that's one piece of information we know. We also know that the area under graph equals distance travelled. So if we were to look at stage 1, it's a triangle, so we could say half the base times the height equals 6 meters, which is the distance travelled. So let's fill in these variables in terms of what we know them to be. So we know that the height is equal to v, and we could call this time here t1, this time here t2, and this time here t3. So if you write that in terms of the variables, we know it's a half t1 times v equals 6 meters, which means T1 times v equals 12 meters. Let's do that again for the other sections. So if we look at stage 2, well, area equals distance travelled. The area is just going to be the base times the height equals 21 meters. The base is t2, the height is v, that equals 21 meters. We'll do it again for stage 3. Half the base times the height, this time equals 3 meters. That's a half of t3 times v equals 3 meters. So we somehow need to try and use these then to figure out our value for v. Well, what do we know? Well, we know one thing that we know that we haven't used yet is we know that all the times t1 plus t2 plus t3 must equal 6 seconds because the total time is 6 seconds. So we could say t1 plus t2 plus t3 equals 6 seconds. Now let's see, can we get t1 in terms of v here? So if t1 would equal 12 over v, t2 would equal 21 over v, and t3 would equal, t3 times v would equal 6 meters, so t3 would equal 6 over v. So we can sub in our values here, our 3 values, and we get 12 over v plus 21 over v plus 6 over v equals 6. Now this is perfect. This is exactly what we want, because we want an equation where we only have one variable that we don't know. And once you only have one variable that you don't know, you can obviously solve for that variable. And the variable that we've kind of rearranged this to give us is v, and that's what we're looking for. So now we just solve this equation to find v. So, well, we've this denominator v, so I'm going to multiply across by v to get rid of that. So every term, remember, every term has to get multiplied by v. On the left hand side, the v's will cancel, and we're left with 12 plus 21 plus 6 equals 6v. That's 6v equals 39. So v equals 39 divided by 6, which is 6.5 meters per second, I think. And that's the first thing they asked us to find. So they said draw a speed time graph, which we've done, and hence find v, which we've done. Calculate the distance travelled at v meters per second. Well, when was it travelling at that speed? Well, that's all at stage 2, basically from here to here. So the distance travelled during that stage we've already actually figured out is 21 meters. So we have that bit answered already.